We have studied the properties of parallelograms. If we have a parallelogram, then what do we know and what are the consequences? Now, if we have a quadrilateral that meets certain conditions, we can determine that it is a parallelogram. So first we went from parallelogram to characteristics. Now we are going from characteristics to prove that it's a parallelogram. If one pair of opposite sides of a quadrilateral four-sided figure are parallel and congruent, then the quadrilateral is a parallelogram. If we have a quadrilateral with opposite sides parallel and congruent, then we have a parallelogram. What else? If both pairs of opposite sides are congruent, then we have a parallelogram. If we have a quadrilateral opposite sides congruent, then we have a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, both pairs of opposite angles are congruent, then we have a parallelogram. If we have a quadrilateral opposite angles congruent, then we have a parallelogram. Now, if an angle is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. If we have a quadrilateral, the angle is supplementary to both consecutive angles, then we have a parallelogram. And finally, if we have a quadrilateral and the diagonals bisect, then we have a parallelogram. Let's see how we can use these properties to determine parallelograms. Determine whether each quadrilateral must be a parallelogram. Justify your answer. How do you know? Okay. Figure A, we have angle, angle, side, angle, angle, side. These two triangles are congruent by angle, angle, side. Therefore, both pairs of opposite sides are congruent because congruent parts of congruent triangles are congruent. So this shape has to be a parallelogram. the triangles are congruent by angle, angle, side. Therefore, both pairs of opposite sides are congruent. Therefore, A must be a parallelogram. B, well, let's see, we have two pairs of congruent sides, but they are not opposite, they are adjacent, so no. This is a kite, but we cannot prove that we have a parallelogram. Number 3, both pairs of opposite sides of opposite angles both pairs of opposite angles are congruent. We have a theorem about this, therefore it must be a parallelogram. And finally, D. Well, we have two pairs of vertical angles. We have a pair of congruent sides. We have a bisector. It is probably a parallelogram. But I do not think that we have enough information to prove. It sure looks like a parallelogram. I worked on this problem for a long time. I cannot find enough information to prove that it's a parallelogram. However, if you can figure it out and prove that this is a parallelogram, I will give you 100 on a quiz and be happy to see your work.